Hi, I'm Nick Trogh. I'm developer engagement lead at Microsoft. Actually, I don't live that far from Lille, just a 30-minute drive. So I feel close to everyone in Lille. So in this session, we're going to look at Azure Machine Learning, and then specifically AI machine learning. As a developer, you don't typically think that is that easy to integrate in your applications. And so what I wanted to show you here is kind of depending on kind of your experience with machine learning, these algorithms, even Python as a programming language, you can still use machine learning. And yeah, you may have heard or you may have played already with the cognitive services, which come as kind of these AI services as REST APIs. But here we're really going to look at actual machine learning and creating these machine learning models and still integrate them in your development, even if you don't know all of these algorithms. And so there's many different kind of applications or scenarios in which you could use machine learning. And so they range from image recognition. Maybe you need to do some sentiment analysis. You want to do some forecasting because you're doing price predictions, for example. There's many different cases. And so looking specifically at machine learning on Azure, as mentioned, there are these kind of prepackaged AI services, those cognitive services, which kind of cover very specific scenarios, whether it's vision or speech detection or language processing. So we have these domain-specific and pre-trained models. So there, your kind of your level of customization is limited to what you can do. Now, then looking at kind of the if we look specifically at this session, what we're going to focus on is the Azure Machine Learning Service. And so what Azure Machine Learning Service is going to give you is basically a set of cloud services and also an SDK, kind of where you that will provide you kind of an end-to-end experience in what we call, and I'll dive into that a little bit later as well, into what we call machine learning ops, so ML ops, where you basically want to kind of manage the whole end-to-end cycle of a machine learning project. And so as you can see here, all of these services, and so here we're talking about Azure Machine Learning, but you could use Azure Databricks, or you can have your own virtual machines where you run your own machine learning code if you'd want to, and they of course run onto on a powerful infrastructure. So you're using the power of the cloud. And very often when you do Azure Machine Learning, especially when you're doing computer vision, you will be using graphical processing units, so GPUs, and so again, there all of that infrastructure you can just grab it from Azure as you need it and scale as you need it. So I talked about this end-to-end process, this whole machine learning operations aspect of data science and of machine learning. And if you look at the end-to-end process of machine learning, really it all starts with having data and preparing that data. So you have all of your historical data, because machine learning is really about how do I take a whole set of data and actually learn from that historical set of data to kind of make predictions for the future or make decisions for the future. So, for example, looking at historical house prices, we can predict how much a given house should be sold for. And so we're preparing our data. And then, of course, you go into a cycle of experimentation. When looking at machine learning and doing machine learning projects, and then I've done quite a few, they are typically, you're spending a lot of time in trying and iterating over using different machine learning models, figuring out what parameters need to be used. And then once you have that trained model, because that takes a lot of time to go through all of these cycles, you're going to basically register your model, and then you're going to deploy that model so that it can be used. Because there's no use in having a trained model if you don't apply it in some application, if you can call that trained model to do your predictions. And so this is what we'll do as well, is also covering that deployment process, and this is what Azure Machine Learning Service is going to provide you. Now, I've talked about machine learning, and kind of trying to and adding machine learning capabilities to your application, regardless of your past experience with machine learning. And so when you look at Azure Machine Learning Service, this is a very much a marketing slide, but it really tells the story quite well, in the sense that Azure Machine Learning Service is really about giving you machine learning for all skill levels. And so the first one, if you're really not experienced with machine learning and creating these algorithms, or even knowing which algorithms exist, because there's dozens and dozens of algorithms that you can use, that you can pick for your machine learning application. But yeah, which one do you choose? Which one is best for a given scenario? And so with automated ML, the service is going to give you basically that whole process of selecting the right model, selecting the right parameters for each of these models, because each of these models comes with, again, dozens, sometimes hundreds, sometimes thousands of parameters that you need to tweak and that you need to modify. And so with automated ML, it's basically going to go through all of these iterations of selecting different models, selecting different parameters to give you kind of the best model for your specific application. And that's what we're going to do with automated machine learning. Now, this has all been slides, so let's dive into a short demo here to kind of show you what automated machine learning actually looks like in Azure. So here you can see the Azure Machine or the Azure Management Portal. And so what I've done already, I've created what is called a machine learning service. So this is the Azure Machine Learning Service. So if you go into Add from the marketplace, you can select here Machine Learning. And that will actually give you kind of the experience to create an Azure Machine Learning service. And so once you've done that, and it looks like my web page is a bit slow here. So as it comes up, let me switch. So there you go. So you can create an Azure Machine Learning service, and this will be kind of your environment where you will do all of your machine learning activities. So switching to one that I've already made here, what you can see here on the left-hand side is basically kind of all of your navigation into the different components of Azure Machine Learning Service. And so I've talked about automated machine learning. And so what we can do here is, how does it actually work? So let's say we have a problem. Our problem is we want to predict, so we are running kind of a bicycle renting service, and we want to predict how many bicycles we need to have ready for, like, say, in the next week to come, based on our historical sales data or hiring data. So we're going to create a new automated machine learning run. And so what we're going to do is we're going to first create from our local data, from some local data. So we have a, let's call it, there we go. And so we're going to browse for our historical data, which is sitting in a CSV file. And so I need to go to code show. There we go. We have our training data, and I'll show in just a second what that looks like. So we're just taking a comma-separated file. We're saying next, so that file is being read. It's going to parse now this data set. It sees here we have a comma delimited file, and our encoding is UTF. Our column headers, so here we're using kind of the first row in our file as our header row to kind of give you the names of the different columns. So here we can see we have date time, we have the season that was used, we have the current temperature, the average temperature, humidity, wind speed, all of those parameters, which can be actually give an indication of how many bikes we're going to rent out on a given day. Yeah, so the count is basically what we want to predict. So we go next, so we can go into the schema. Here, potentially, we can remove some columns which we might say are not relevant. So for example, here, casual and registered, they're not relevant because they are just a subset of our count, which we're going to calculate. We just say next. We confirm, basically here. There we go. We have our data set now. And so what we're going to do based on our data set, we're going to say, what do we want to predict? What type of machine learning do we actually want to do? And so here I can do our demand. Let's call it meetup. We need to specify what column do we want to predict? What column do we want to forecast? In this specific case, we want to forecast the number of bicycles that we want to rent. So this specific count column we want to predict. We have some compute here running. We can say next. So and then specifically what we want to, so we have indicated this is the specific column that we want to predict. Now, what specific task are we trying to kind of accomplish with this automated machine learning? In our specific case, we want to do forecasting, time series forecasting specifically. We want to predict values based on time. So we've had historical data. So for day 1, 2, 3, etc., for each day we have a number of bicycles. So it's time-based predictions that we want to do. And so we are going to specify what is our time column. Our frequency, we can keep that one. We want to say how many days in the future do we want to predict. So let's say we want to predict like 2 weeks. We can specify some additional parameters here. If you're familiar with machine learning, you can customize all of this. In this specific case, we can leave all of the settings by default. We can add some explaining here. And then when we do finish, this will actually create now an automated machine learning run. So what's going to happen is the machine learning service is going to look at our data. It's going to look at, this is the column I want to predict. I need to do forecasting. So I'm going to try out this whole batch of machine learning models, algorithms, and go over them in parallel and try all different combinations of algorithms plus different configuration parameters. This one could run for about an hour, so we're not going to wait for that one to complete. So what we'll do is, let's take one that have already been run here. So here I've run on the same data. I've run already this automated machine learning model. And so what we can look at here in our models, there we'll actually see all of the different machine learning algorithms that have been tried out by the service. So you can see that there's a whole batch here, and there's, I think, 4 or 5 pages of these algorithms that have been tried out. And basically here you can actually see what is kind of the error rate. And so for this specific column, lower values are better. So this is kind of the error we have, and so the lower the margin of error is, the higher your accuracy of your machine learning model. And so in this specific case, it has used this stack ensemble algorithm to kind of come to the best kind of machine learning model to rule them all, basically. Yeah. And so what we can do is, so here you can see all of the experimentation happens automatically. The only thing I need to do as kind of a developer is specify what is the column I need to predict and what type of problem is it. So it's a forecasting problem. And the service is going to go its way to try out all different variations. So that's kind of easy. Now, next thing we need to do is, of course, well, we want to deploy this best model. Because, yeah, now we have a trained model, but yeah, how do you use it? And so if we want to deploy it, so we can do this straight from the portal here, is by clicking this deploy button. So we could say bike demand. Right. We're going to deploy it where, let's pick Azure Container Instance, but just as well, you could use AKS. And we could specify some parameters if we want to. Do we want SSL? What kind of CPU and memory requirements do we want for our container instance? Because our model, our trained model, is going to be deployed as a Docker container. And so when we click on deploy, it automatically is going to generate the Docker image for this specific service. and going to package basically all of the code that is needed to expose it as a REST endpoint. Okay, so the service has generated basically the binary, the trained model, and then as we deploy, the trained model is going to be packaged into a Docker container, including some code, some Python code, to actually expose that trained model as a REST-based API. And then as we have that API up and running on Azure Container Instance or on Azure Kubernetes Service. Okay, so we have our API. Here our bike demands API, which is running. We're still waiting for the REST endpoint to land. So what I can do here is take already one, which I generated yesterday. And so once you have deployed your automated machine learning model, we can actually grab this endpoint. And if I go to Postman in this specific case, I have my scoring endpoint, which is this one. I give it some parameters. So I give it a date. I give it some parameters. So what are the weather expectations, temperature expectations, and based on that information, it's going to give me some forecasts and going to say, well, we have a forecast of 574 bicycles that will be rented out. So you might wonder if, let's say, we change this to maybe 10 p.m. What's the impact of that? Well, probably we're going to rent out only 86, which is kind of makes sense because the later in the evening, there's going to be less people that will be renting a bicycle. Okay. So this is kind of a quick tour of automated machine learning, how that works. Yeah. So training happens automatically on the selection of the algorithm. The deployment is quite easy to deploy it into AKS or ACI as a Docker container. Now, what is this next step? So in this first step, we don't need to know anything about models and algorithms. In the next step, maybe you're a developer that knows a little bit about machine learning algorithms, but you're kind of not used to kind of writing Python code, but still you know kind of the what needs to happen from a logical perspective and how to build a machine learning model and build an application for that. And so for that, we have what is called a designer. The Azure Machine Learning Service has a graphical designer where you can actually drag and drop specific algorithms and have some level of customization by means of either R code or Python code that you can also include in that graphical designer. So when I switch back here to our portal, we can go to the designer view here. So we've covered kind of the automated machine learning part. Now let's say we want to kind of do a similar problem. We want to predict a car price, which is what we call a regression problem. So we're trying to calculate a numerical value, kind of the price of a given car. So what we can do here is I need to select some compute target. I'm going to use my training cluster. There we go. And we can close this one. And so what you see here is just an example kind of machine learning process, what we call a pipeline, where first we start from a data set. So we have a comma-separated file of car pricing data. Then we're going to select some columns there. So we're using all of the columns, but excluding, for example, the normalized losses. Then we need to do maybe some data cleaning, because maybe not all of the columns are filled in. Maybe there's some rows which have some bad data. And so what we're doing here is we're going to do some cleaning up of missing data. And so what happens is if there is, for any of the columns, if there is a value missing, what we're going to do, the cleaning mode is just to remove the entire row. Potentially, you could replace it with kind of the mean value or with the median value, if that would be kind of better for your specific scenario. And then the next step in this pipeline is where we're going to split the data. So we're going to take, in this specific case, 70% of the input data. We're going to use that for training our model. So kind of the basic scheme when you do machine learning is you take a subset of your data set and you use that for training your model. And then the rest of your data, you're going to use it for what we call scoring your model, kind of for testing the accuracy of your trained model to see when, well, we've trained our model now on some information, on some data. How is it actually doing when we give it new data, when we give it data that it hasn't seen before? And that's what happens here in this scoring model. So here you can see the data flows into our trained model. This is 70%. And then the other 30% will be fed into the scoring model thing. And so what model are we using here? In this specific case, we're using what is called a linear regression. And so here we have different algorithms. So if we're looking at regression, for example, let's say we want to use a boosted decision tree rather than a linear regression. So we can remove this one here and just connect this one here. And now we've used a boosted decision tree for doing the kind of solving our problem, our prediction problem, rather than a linear regression. So if you know some algorithms already, well, you can just use this here. And so you get kind of this very user-friendly, this graphical experience. If you already have maybe some custom Python code, well, this is what you could do as well. So you can just insert here maybe some Python script, and then here over on the right-hand side, you can actually kind of fill in all of the Python code that you want to have executed as part of your pipeline here. So let's get rid of this one here. And so as we continue, we have our training model. We're then scoring our model. And then in the end, what we can do is we can evaluate, kind of look at, well, how well did our machine learning model actually do? Okay. So what we can do now is you can submit this job for training. And what will happen is this specific pipeline will be now submitted to our training cluster, and it will actually go and execute this specific machine learning pipeline, and it will give us a trained model once it has finished training. So again, this takes a little bit of time. And so what I've done again here is I've created one already before. So when we go to automobile price prediction, what we can do, what you see here is actually when we look at, for example, our evaluate model, and right click and we say visualize. Here again, we see these numbers of what is our absolute error. We can see some kind of indicators of how well our model is actually doing. So we can see the relative squared error of 0.13, etc., etc. So you can get some indicators here. And so this is our trained model. Now, if we want to use this model, again, in a similar way that we had for the automated machine learning, we can go to what is called a real-time inference pipeline. So in machine learning, when we talk about inference actually means using your trained model to do predictions. So this is what we call an inference pipeline. And so what happens is this one can be generated from our trained model. And what happens is you can see here that we get a web service input, we get a web service output, and that will feed into basically our trained model. And so this allows us to kind of also then to deploy this model to container instance, to deploy it to Azure Kubernetes service. So again, package your trained model in a Docker container in the same way as we had for the automated machine learning. And so once we've done that, again, we will get what is called an endpoint. Yeah, so we have our car prediction service, which again will get an endpoint. In my specific case, again, it's going to be based on or deployed on Azure Container Instance. So we can go here to Postman and again do our car prediction. In this specific case, we're doing car price prediction. So we need to give we give the brand, we need to give the fuel type, is it four-wheel drive, etc., etc. And when we run this one, it will give us a output, and it will give us what is called a scored label, and it will give us an actual price indication of close to 14,000, I think it's US dollars in this specific case. So very similar, but to the automated machine learning. However, here with the designer, you still have a little bit more control over what is the actual process and cleaning up all the data and doing some additional customization. The designer we've gone through. Now, what is kind of the next step? And I'll wrap up with this one here, is that you're really using what is called notebooks, machine learning notebooks. And so notebooks allow you to kind of write your own Python or R code and actually create your own custom machine learning process, even write your own machine learning algorithms using existing frameworks, or maybe you just want to write it from scratch. And so with notebooks, you get this environment where you can actually just write your own Python code. And so here you can see an example of such a what we call a notebook or a Jupyter notebook, which is kind of the most common way of doing kind of data science experimentation, is where you write basically a notebook which contains some textual information, some documentation, as well as the actual executable Python code. So you can execute this, and this will actually execute Python code on basically on your Azure Machine Learning service. So all of this is being executed in the cloud. And so here you can actually start writing all of the Python code to create a cluster. And so what we're going to do here is actually do what is called computer vision, where we're trying to recognize numbers based on kind of images of numbers. And so here you can actually see the training script. So if you are familiar with Python and machine learning problems, you can actually see here that we are doing a logistic regression. We give it some parameters. We do the fit, which is actually the training process, and then we do a predict, which is what is called the inference. So we're predicting actually the values based on our test set of data. Yeah. So training, predicting, and that's basically your machine learning process. And so here, as you can see here in these notebooks, you have full control over what you want to do. Either write your own algorithms, write your own models, use existing trained models, do whatever you like and run it on Azure Machine Learning Service. And it integrates with exactly the same capabilities that you had with automated ML. So you can have your trained models here. There you can see this one, which you can then again register or deploy that specific model to either a container service or a container instance. So we've gone through let me forward to this one here. So we've gone through kind of the experience of, hey, I want to use machine learning, but I don't know anything about algorithms and configuration of them using automated ML. Through kind of this visual experience where you do know a little bit about machine learning, but maybe you're not kind of too experienced with Python and writing all that code to kind of create that full process. All the way to these notebooks where you can actually have full control and full flexibility of what you want to do and what you want to achieve using machine learning. So as mentioned, machine learning service, machine learning for all skill levels. So I hope you've kind of seen how that actually comes to practice. I want to give you some links here. Those are links to the actual sample code that I've shown you, and hope you kind of enjoyed this session. And if you have any questions, let me check the